today. My name is Chuck Fuscello. I'm the President and CEO of the Alzheimer's Foundation of America, and I want to welcome all of you. This is part of our stop today here in OKC is part of our Educating America tour, which we started 2 years ago, and we've been traveling throughout the entire country because we feel it's critically important that individuals who are educated about Alzheimer's disease know that there are places to turn to for guidance, counseling, and support, and that's what today is all about. So thank you so much for being here. A few things before we get started. We are offering memory screenings today, free memory screenings outside in one of the rooms. You could just see Amanda, who is the woman that checked in. Is Amanda outside, Chris? Just ask her to come in for a minute and say hello to everybody. Amanda Gonzalez is an employee of AFA. We're delighted she's here, but she offers free memory screenings, and when she comes in the door, we're all going to say, hello, Amanda. Hello, Amanda. Amanda, it's not your birthday. We'd love to sing happy birthday to you, but we wanted to give you a big welcome. If anybody wants a memory screening, please see Amanda. Let me ask you a question. Who's afraid to get a memory screening? Be honest. Okay, good. Even our keynote speaker, Dr. George Perry, said he's afraid. Don't be afraid, non-invasive, a series of questions just to test your brain, your skills. It only takes a few minutes. You get a baseline score. Amanda will talk to you about it later. But once again, thanks so much for being here. Today we're delighted to have Dr. George Perry, who's a professor of the College of Sciences and Seams Foundation, Distinguished University Chair in Neurobiology at the University of Texas at San Antonio. He's also a member of the Alzheimer's Foundation of America Scientific and Medical Scientific and Memory Screening Advisory Board. Dr. Perry is considered one of the top Alzheimer's disease researchers throughout the entire country with over 1,000 publications. You know, he's a close personal friend, and I have to tell you, we're delighted he's here. His schedule is too busy even for himself, but he's a key component, important to the success and the mission of the Alzheimer's Foundation of America. Ladies and gentlemen, please welcome Dr. Perry.
One, two. Thank you. There it is. Thank you very much, Chuck. Yes, I have it. I think, is it not? See, already I didn't pass the first memory test. Look. It isn't working? Okay. What's wrong? You didn't do the sound test on this unit.
We did it earlier.
What do we need?
I guess it needs to. So
Okay. No, it's okay. Is this working now? It is? Okay, it's okay. Well, thank you. And I guess my voice now will carry back to the back of the room. Thank you very much for having me here. I'm going to present a mixture of things that affect patients and the research I do. The research I do is mostly neuropathology, which means it's mostly focused on diagnosis of people after they've passed on. I do research on human brains of people with Alzheimer's disease and animals and proteins, etc. So I'll mention something about that and also about how Alzheimer's disease affects us. The work I'm going to present, the actual research, is I collaborate with people throughout the world, and this is just a list of some of them, people at the University of Texas, Case Western Reserve, where I used to work, and at other locations. Well, Alzheimer's disease, I've been involved in the field since 1982, and it's really transformed itself. In 1982, almost nobody knew when I said, I'm studying Alzheimer's disease, they'd say, what? And even among scientists, it just wasn't a well-known characteristic. And now it's moved to something where everybody knows what it is, and everybody's concerned. Even I'm afraid to take the memory test, or the APOE genotype, or all of these things. And it's something that's very disproportionate. Alzheimer's disease will probably affect about 1/3 of families during their lifetime. But about 85% of the people are concerned. And you could say that's true about all of the things that affect morbidity and mortality, but it's not. People are less worried about cancer, less worried about heart disease, both of which are more common. And why is that the case? Why? Because Alzheimer's disease is it's something that you know affects you very deeply. One thing is people are living a lot longer, and as we'll show later, that small bit that people live longer, which is small like a decade or so than they did a few years ago, puts people at really much higher risk of developing the disease. So that's why the incidence of the disease appears to be increasing, because of people living beyond 75. When you get to 85, your chance is about a third to a half you'll have the disease. And I think much more is the social aspects of the disease. So far, the disease is incurable and almost essentially untreatable. The effects of Aricept and Namenda is very small. It does have benefit, but it's still very, very small. So there's no really effective treatment. But definitely, there's nothing you can do to cure it once you have it. And that's not true for any of the common diseases that are affecting people. Heart disease, cancer, and on, have treatments, and some cases have what you could say are cures, at least put things in remission. But as you also know, and I think even more why you're here today, families are emotionally and financially burdened by the disease. It's one of the most costly diseases to have because of the care situation. And to see your loved one, you could say it's dying twice, or whatever it is, it impacts people really strongly. As where with other diseases, there may be a financial burden, but your loved one is not detached. There's a detachment between the mind-body connection in which the mind is being lost and the body lost later. It steals our consciousness. It eventually steals our identity, and you're left with a shell if you go through the full piece. As you all know, too, people in the early phases of Alzheimer's disease maintain a lot of function. You don't need to have an IQ of 180 or 100 to have a full life. As you're progressing through Alzheimer's disease in the initial phase, it's important to remember people have a life. Okay, how about the increase in, probably most of you know this, that the amount of money that's being spent for Alzheimer's disease is estimated in the US at $1 trillion. And how you view these estimates really depends whether you consider just the direct costs of taking care of patients, or do you consider the uncompensated caregivers that many of you are now giving and changing your work patterns, etc., which is also impacting. And this in the next 15 years or so is going to be for the US $2 trillion. Even if, because the number of people, so baby boomers get into an age at high risk, there's going to be increasing numbers of people with Alzheimer's disease. Across the world, there's going to be, right now, maybe 50 million people are estimated to have Alzheimer's disease. It's going to increase to 152 million in just a short period of time. And it's important to note that probably most of the growth of demented people is going to be in the third world, where there's a lot of young individuals and populations are aging. So it impacts people throughout the world. I've been studying Alzheimer's disease since the early 80s. I actually had no one in my family that was demented, and I studied hundreds of people that were deceased. But the first person I actually ever knew that developed Alzheimer's disease as I knew them was a donor to our college. And this was Glenn Biggs, who was a very prominent Texan, the perfect Texan, very tall, and spoke with a deep voice and knew all of the Texas prominent politicians, etc. And I saw him change over a very short time. Even his social skills couldn't compensate for all of the cognitive changes he had. And now the Health Science Center, which is separate from UTSA, has in his honor an Alzheimer treatment center. So I think that's one thing, is you study Alzheimer's disease, and the other part is when it touches you. Fortunately, it hasn't touched my family yet. Our family tend to die of other things. But if you look at causes of death, modern medicine has really done a good job, and I will come back more about heart disease, which has continued to be reduced. Heart disease is never cured, but it's continued to be reduced by a number of different things that are done. But if you look at like treatments like HIV is moved from a death sentence to a chronic condition, et cetera. Almost all the common diseases are reduced to some degree by modern treatments. Alzheimer's disease is still increasing. So I mentioned before about the linkage to age is that it doesn't follow that if you live to 100 or 110, you're going to get Alzheimer's disease. But your chance that it's going to happen is very high. And if you look here at your chance of having Alzheimer's disease, if you're in your 60s and 70s, it's relatively low. But once you get into the 75 to 85, and if you live beyond 85, which is considered the oldest old by definition, not me saying being ageist, is that you can see your chance for different groups ends up being between 30 to 60%. Also, there's an interesting relationship. Minorities appear to be more affected. Well, the statistics are that they are more affected. You can see here that African Americans are almost twice as affected, and Hispanics are twice as affected as the white population. And we really don't know why this is the case. Is it because of different health things? Is it because of genetics, educational patterns? It's still being worked on. This is the famous type picture taken from the web of showing what happens to the brain of somebody with Alzheimer's disease. The normal brain, our skull has a cavity in it, and the brain sits in that cavity, fluid-filled cavity, and fills it up, and your neurons, the things that think, are in this outer area, which is called gray matter. In this case, you could call it brown matter, but outer area. And people with Alzheimer's disease, at least in the advanced case, would have the brain shrunken. Especially this area here, which is the hippocampus. It's the area associated with memory. It's the area that integrates recent memories to more permanent memories. And that's why intermediate memories are affected quite early. You notice also the hole in the brain. Everybody has a hole in the brain. It's a normal thing because the fluid circulates, but it's larger in somebody with Alzheimer's disease. And you can see the whole brain tends to be shrunken, at least in late stage disease. Okay. When Dr. Alzheimer described August Dieter, the archetype of the disease, the woman who in her 50s had Alzheimer's disease, he was able to do so because they developed specific stains to look at the brain, a way to color the brain. So what Alzheimer did during that time, people, instead of thinking there were evil spirits or Freud's idea that your mother didn't take care of you or something like that, trying to find excuses about why you were crazy, they actually were looking at saying there must be something wrong in the brain. And during that time, they analyzed people with various types of psychiatric condition, and Alzheimer's is a psychiatric condition, and looked at the changes that were in the brain. And what they found was very much like this image. So they found plaques. This is a light micrograph from a light microscope. And this is the same thing with a more modern stain using antibodies, and those are the plaques, which are really small structures. They're about 20 microns in diameter. No, let me go back. And the other thing he described was the neurofibrillary tangle. So there's been a lot of focus on looking at why these abnormal structures are there, and if you remove them, everybody's going to be healthy. And I'll have much more about that as we go along. So over the period, especially since the late 1970s, when people appreciated Alzheimer's disease as really a major public health issue. That's when people realized it wasn't just a disease of middle-aged people like August Dieter, but it was the same disease that was affecting older people, which is much more common. There have been at least 130,000 high-profile papers published. My estimate is there's been at least 60,000 people involved in studies of Alzheimer's disease. There's been a lot of money going in from people like the Alzheimer Foundation, the NIH, the Bright Focus Foundation, etc. But what's important to know is that the current therapeutics are based on ideas that were developed before I entered this field in 1982. In fact, one of our advisory members was critical in developing Aricept, Peter Davies. But in terms of beyond this ideas from the late 1970s and developed therapeutics that had some benefit but not great, all of the recent drug developments have failed. In fact, there's been a 99.6% failure rate. And this estimate was done by another member of our advisory board, Jeff Cummings. And that was a few years ago, so I think now it must be 99.8 or 99.9 because there have been no successes in between. So there's been at least 400 or 500 studies, and only one during that time period worked. That was Namenda. So what we've asked is it because there's been too long a focus on removing the pathology of the disease before we even understand what the pathology is doing? And because especially in the last year and a half, the clinical trials that have focused on removal of amyloid, the vaccine trials, specifically the studies of Biogen, were extremely successful in removing amyloid from the brain. So they removed the amyloid and the patients did not get better. So where do we go from here? Do we just keep trying to remove amyloid, which not one of the studies have succeeded, or do we go to tau, or do we go to a different understanding of the disease? I don't have a complete answer for this, but these are some of the things I think are important to address. So our studies, at least over the last 20-some years, have focused on a specific aspect of Alzheimer's disease, a fairly unique aspect. We're not the only ones that study it, and that is the idea of oxidative stress. How many of you take vitamin E or vitamin C? So maybe half the people take it. And how many of you think it's a good idea to eat lots of vegetables? Okay, even more. So the reason why you're doing that is because you're trying to prevent your body from rusting away. Okay? Just like nails rust, we rust. And just like you eat food and the food goes through your body, it oxidizes, just like in a car. Doesn't have pistons, but it oxidizes. At the same time it oxidizes our food, it also reacts with us. We're not 100% efficient, just like the car isn't. And the side products of that oxygen going through us react with us, and our body deals with it all the time because we've had oxygen in the atmosphere for nearly 1 billion years. It's not a new thing, in terms of evolution of life, but we've been trying to understand, are there alterations in this process? Because one of the theories of aging is oxidative stress balance underlies why people age as time goes on. So we did, and I'm going to probably try not to go over all the details, we looked at neurons of people with Alzheimer's disease. All my slides are included on there, and I can send more material if you write to me. Is that we looked at whether there was modification of molecules that by oxidative changes, and we found that they were modified even more than we could have imagined. We thought that they would only be modified in plaques and tangles. And what we found was that they were modified throughout the neurons that are at risk of dying, the ones that cause the brain to shrink because the neurons die. And neurons are what communicate all your information in your brain. So if they die, they can't do that because they're not there. Is that we were able to find sugar, which is a process called glycation, which is important for hemoglobin H1C. It's a glycated form of hemoglobin, but it also refers to other proteins, protein oxidation, nucleic acid oxidation, like DNA and RNA. So the fundamental genetic material is modified during Alzheimer's disease. And we found that it was modified specifically in the neurons that are at risk of death. see. And this led us to really center on the structure that actually is the engine of our body. So every cell in your body, except for red blood cells, have these little structures in them that are about the size of bacteria. And they are the structures that eventually metabolize all your food. They turn it into the energy currency of the cell, ATP. And they're these structures, and I'll show much more of these in more subsequent, these very elaborate structures that produce 95% of the energy you use. They also, since they're taking in oxygen and producing energy, they are the ones that produce the toxic oxygen products also. So we wanted to know if they were altered during Alzheimer's disease. Was that really underlying the oxidative stress phenomenon? And then I'll bring it back to where this sort of fits into the disease. So we did something, we looked at, mitochondria are really neat. People think that they derive from bacteria that crawled in our cell. Kind of creepy. Okay, that some bacteria crawled into our cells 1 billion years ago, and they continued to function. And why they think that's a number of reasons, but one of the most striking one is they have their own DNA. It's the only part of, normally all of DNA is in the nucleus, and mitochondria actually have their own. So we looked whether that mitochondrial DNA was different. And what we found was that there was a big accumulation of mitochondrial DNA in Alzheimer's disease, which really couldn't understand when we found this. How could there be more mitochondrial stuff if everything's so screwed up during the disease? So we found there was more mitochondrial protein. This is a stain for mitochondrial protein, and this is a section through a normal brain, an older individual, same age as somebody with Alzheimer's disease, and you'll see this also. This is called in situ hybridization, and mitochondrial DNA was increased about 4-fold. So this paradox was, wow, that there's more mitochondria, and yet mitochondrial activity was slightly reduced. Had it been in prior studies, and we confirmed that. So we looked at biopsies, samples that were taken from living patients early in the course of the disease, that were taken from a long time ago when that was considered to be normal medical practice. It's no longer normal medical practice to do biopsies on people. Why? It doesn't have any treatment value for the impact. But prior in the 60s and 70s, they were taken. So we looked at the mitochondria and classified them, and we found, if anything, there's a slight decrease in the number of mitochondria, even though there's more mitochondrial DNA. And the reason is, this is with gold nanoparticles looking where the DNA is. In addition to being in mitochondria, most of it is in mitochondrial junk or fecal material within cells. Cells also produce junk, and they need to get rid of it. And you see a whole bunch of mitochondrial DNA and other products all present in this garbage system. It's called lysosomes. So this led us to then think, wow, why are the mitochondria so screwed up? Why is there all this mitochondrial garbage? And there are at least 3 things we could address. I'm only going to talk about 2 of them. We could look at how they're removed, and that I won't present. But the thing we've studied the most is this process called fusion fission, because mitochondria actually are super dynamic in cells. They fuse together, so you can have a cell with one mitochondria and like a bunch of threads, or you can have a cell with 1,000 mitochondria that are like little balls. And you can have still the same amount of mitochondria. And why is this important? Well, I'll tell you in the next couple of slides. The other thing is that they move. And this is especially important in neurons. You have neurons in your body that are close to 3 foot long. They're not the ones affected in Alzheimer's disease, but they're in the back of the spine and they go down to your toe. And to get a mitochondria down to your toe, it has to be transported. And it's transported on a structure called a microtubule. And there's little motors that do this. They aren't like cars. They move along and they use energy and kind of transport things both ways. So why do you care if you have 1 mitochondria or 1,000 mitochondria? Well, the answer is probably either one is bad. You need to have dynamics. Life is full of dynamicism. Just like you're dynamic, your body is dynamic. When it stops being so, it doesn't function very well. So what happens is mitochondria very often become defective, especially the DNA, because there isn't a good repair mechanism. But there's tons of copies of this. It isn't like your normal DNA. So what you can do is mitochondria, if they're defective, they can fuse together and fix the problem. Alternatively, they can become all these little separate pieces and you can get rid of all the defective ones. So sometimes it's better to get rid of them, sometimes it's better to repair them. That's what the dynamics is. Another part is, if the thing is 1 mitochondria for the cell, it's going to be impossible to move it down the axon, down that process, down to your leg. In the brain, they're not 3 foot long, but they might be inches long, and that's still long for a cell. So we looked at the microtubules in biopsy specimens, so living patients, samples removed from living patients with Alzheimer's disease. And this is a quantitative study done by a student of mine. And we counted the number of microtubules, which is not as hard as it sounds like it is that we counted them in people with Alzheimer's disease and matched controls. And we found there was about a 90% decrease in the microtubules. And this is the type of images we looked at. These are microtubules. Those are the tracks that things move down in cells. And this is a neurofibrillary tangle, the thing I showed earlier. But this is an electron micrograph, and that bar, these structures, that one is 25 nanometers. So these are really small, high-resolution pictures. So microtubules decrease during the disease in a very profound way. But the other process that's even more obvious is the fusion-fission process. And this is also extremely regulated by a number of proteins. And those proteins can be analyzed by gel electrophoresis methods. And you can see, I'm going to focus on one protein to make it simpler. We're very thorough, but I don't need to tell you about our thoroughness. It'll even make it more confusing. Dynamino-like protein, you can see that there's a lot of it in normal people, and there's a big reduction, about a 75% reduction in people with Alzheimer's disease. But what's really neat is that we see a similar pattern if we look at skin cells from people who had Alzheimer's disease versus normal people, which to me still amazes me. How does the skin know that somebody had Alzheimer's disease? And what we see is that the mitochondria, and in this case these are living cells because we can grow them in culture, and they're skin cells. They are not like neurons. They easily grow in culture. And you can see that they have mitochondria either clustered around the nucleus, that's the central part of the cell, or dispersed all around. And what we found was that the mitochondria came from somebody with Alzheimer's disease. They were more likely this clustering around the nucleus. And although these are small numbers, you'll understand why more later. We've actually taken those skin cells and turned them into neurons, but I don't have a complete data set to show. You can take skin from a people and convert it to neurons. Pretty neat also. But in a more complete analysis, what we did is we looked at some other cells and looked at whether these proteins, like dynamino-like 1 protein, really regulated how mitochondria were distributed in cells. And we found that in normal situations, well, it may be hard to see, but there are little dots all through the processes of a neuron. The main function of neurons is to connect with neurons. They're like transistors with little wires of dendrites and axons receiving information and deciding whether they got enough information to fire, much like a transistor in a computer. And if they don't connect and don't have energy, they can't do it. So if we take dynamino-like 1 protein, which I told you is reduced in the disease, you can see the mitochondria have big gaps in them, although the picture's not that clear. So what we found, now why are we seeing these differences? One is we know oxidative stress causes some of these issues, but amyloid protein also plays an important role. The thing I talked about that if you removed doesn't seem to make a big difference for patients actually plays an important role in mitochondria. So if we take people and overexpress amyloid protein in it, we see much more of this collapse morphology. If we put the protein in cells of a amyloid precursor protein that has a mutation associated with vastly increased chance of having the disease. In fact, they will have the disease. It's a so-called Swedish mutation. They even have a greater amount. Now we're able to increase these to over 50%. And we were able to show that this change with amyloid precursor protein is definitely related to its production of amyloid. In the previous slide, I didn't point it out, but if you block the formation of amyloid, you don't get this change. And you can also correlate the two things. We actually measured how cells recover in terms of this fusion fission. You can directly assess this. And if you have amyloid protein present, you have about 1/3 reduction, about a 70% reduction in the mixing of mitochondria. So the conclusion of this part of my talk is that what happens in normal people is that the mitochondria are distributed throughout the cell where their energy is needed, where you need to be able to connect, and all those functions of neurons require a tremendous amount of energy. The brain uses about 25% of the energy of the body. And yet it's, really a small part of the body. It's only around 2 pounds. And yet it uses, so its energy in general is probably about 10 times the average for the body. It's not the only part of the body that uses a lot of energy. I mean, the heart uses a lot, and so the kidney. But it's really dependent on that. And what happens during Alzheimer's disease is the mitochondria are not clustered where they should be. You see all this mitochondrial garbage around in the cell body. You see them with big gaps in between. We actually know those gaps occur really in brain because we measured it. And we think this creates a problem for how neurons connect. Okay, next part of my talk is about, I talked about the clinical trials with amyloid didn't succeed. Then I said, wow, oxidative stress and mitochondria appear to be really integrated with the amyloid. So why didn't it work if what I presented so far was true? So we looked actually observational studies and looking at oxidative damage, which is something we can measure. In this case, we looked at oxidative damage as marked by something that's blue. And this is oxidation of RNA. So a critical part of how genes are made. And these are people with Down syndrome. People with Down syndrome develop Alzheimer's disease changes when they're very early in their teenage years. So a teenager with Down syndrome has high levels of oxidative damage. If I showed a control, there'd be nothing detectable at 17 years of age, and have very small amounts of amyloid, as marked here by the brown. When you look at somebody who's 61, and that's old for somebody who has Down syndrome, older, you see prominent plaques, but the neurons are not even stained. So we quantitated this and found that the oxidative damage in Down syndrome precedes the amyloid change by at least 10 years. And that, at least by 10 years, and that there's this inverse correlation. The more amyloid there is, the less oxidative damage there is. So that's a correlational observational thing. It has R squared of 0.95. So it appears to be related, but in an inverse fashion. We thought that was kind of amazing. Like, how could amyloid actually have the reverse effect of what we thought? So we also looked whether this pattern of oxidative stress being early was true in normal Alzheimer cases, not just Down syndrome. And we collaborated with Washington University in St. Louis because they had incident cases of Alzheimer's disease. They assessed normal people and watched them as they develop Alzheimer's disease. And that takes it's a big study because most people that you'd follow would never develop the disease, and if they do, they probably don't die. But some of them do, and those were available for our study. And when we looked at that, we found that people had the highest level of oxidative damage actually really early in the disease. Mild cognitive impairment is the highest, and I'll show more of this, kind of this pattern. The oxidative damage is really early and then reduces. So this is controlled. This is the earliest phase of Alzheimer's disease, even before MCI. You probably wouldn't even note this in a family member, but MCI you would, and then it actually drops as the disease progresses. And this is specific to the neurons at risk. That's what the comparison, because this is cerebellum that's not affected so much, and you see there's no difference. Again, looking at this in sporadic Alzheimer's disease, and through the course of the disease, you see the same pattern we saw in Down syndrome of the reduction, not so linear, but still correlated with and highly significant, of an inverse relationship. More amyloid, less oxidative damage. Oxidative damage is on this axis, and this is the amount of amyloid. And if you look at duration of the disease, again, a progression. So people are diagnosed and die at different times after diagnosis, and you can see again this clear drop. So why is there this clear drop? So we tried looking at why there would be a drop related to the amyloid directly. Correlation doesn't answer that. So in the initial studies, we looked at plaques themselves, which are structures that can be isolated from the brain, and that's what this is. This is a plaque that's been isolated, stained with a stain called Congo red. And Congo red, when viewed under polarized light, has this structure which looks like a cross of Maltese cross. It's a stain with antibodies. I collaborated with somebody. I barely understand these little squiggles myself, okay? But this little squiggle and that little squiggle means that there's copper and zinc bound to the plaque, okay? And why is that important? I'll show you in a couple more slides. So when you look at oxidative damage, why I mentioned rusty nails is because the body uses iron and copper for all of its oxidation reactions. When you're breathing and your food is oxidizing, it's going through iron and copper. Every molecule of oxygen is going through iron and copper in the mitochondria. And it's oxidizing it, reducing it, oxidizing, reducing. So we wanted to understand is that's what's the basis of the effect of amyloid. So we again isolated plaques, and this is showing it by a different microscopy technique called scanning electron microscopy. And you can see here a plaque kind of looks like a pon-pon from cheerleaders, like a frilly little ball. And those are the filaments. This is the light micrograph. But we did something really high resolution in this electron micrograph. We looked at it to look where the metals were organized. And we were especially interested to understand where the copper and where the iron was, since we didn't see any of the iron when we did the Raman spectroscopy. And you see these little dots that don't look very impressive. Well, I had been doing micrographs and these things for 30 years, and I wouldn't have noticed these, okay? It depends on how you look at them. Those are only 10 nanometers in diameter. That's really small. Those structures turn out to be pure magnetite crystals. So within the plaque, these are, again, looking at those particles. Now we're looking at an individual particle, and you see the size? We're gone to angstroms. We're actually looking at individual atoms. This microscope can see an individual atom, at least of larger atoms like metals. And this structure is exactly the crystal structure you would see with magnetite. So those crystals are pure magnetite. And then a magnet, so you think, there's got to be a magnet there somewhere. Well, the answer is you can actually look at the magnetism. And that seems like that would be trivial. It's not trivial. It took me 20 years to find somebody that could help me to do this, because they do not have direct magnetic properties. They have a property called superparamagnetism. It means they have magnetism when they're in the magnetic field. not directly, and it has to do with the size. So we actually were able to measure that directly by this technique. To go further, we're working with a group in England using a synchrotron radiation to actually map all of the metals. And those studies are ongoing. We published one last year. We're continuing on. Another technique we're using is a mass spectrometry technique where we're able to look at atoms, and we're able to produce images of the brain that are not dependent on old techniques. So this is actually a mass map of different amyloid proteins. And why are we doing that? Because we want to be able to understand everything about how these structures function in real brain. Most people I think almost all of our competitors study things that are not derived from the brain. And things that are in the brain are different than things you buy from a chemical bottle. We also study the chemical bottle, things that are produced synthetically, but sometimes they're quite different. And why we're interested in the metals really is in this experiment we did several years ago, in which we looked at the ability of copper to cause oxidative damage to the body. And if you just take copper and mix it with fats or with vitamin C, it'll oxidize it. If you mix amyloid beta with it, it inhibits it. And that's what this is. This is with no amyloid beta. As you increase the level of copper, you end out more and more oxidation, and that's true for vitamin C. It's true for, in this case, lipids, unsaturated fatty acids, which are some of the most toxic products of oxidation. If you add amyloid to it at a ratio of 1:1, it pretty much blocks it. So this led us and made people probably extremely angry with us, is we wrote about 15 years ago, well, beginning 20 years ago, in this picture probably about 15 years ago, that treatments that focused on removing amyloid would probably be detrimental to patients. And why? Because the amyloid is integrated into the response of the brain to the disease. And so we suggested that neurons are actually figuring a way to avoid death during Alzheimer's disease. And amyloid beta, that's like a survivor, like a life raft, that's actually keeping the neuron alive rather than killing it. And that removing this life raft would actually make things worse. When we put this, that was of course pretty bold and a little bit of a guess on our part, although it's consistent with our data, but it's totally consistent with the failure of the clinical trials, that they will not work by just simply removing amyloid. In fact, could cause more problems. Okay, so most of my talk really focuses on the issue of oxidative stress and mitochondria. But I could have given a talk on at least all of these topics. Amyloid deposition, I could have talked about tau, I could have talked about antioxidant responses, because there's tons, much more than amyloid. I could have talked about the cells trying to divide, which they do. And the list goes on. Okay. But these are just the things that we studied in my laboratory. So I could make up a new theory of Alzheimer's disease, and I could have written 30 different articles saying those were the cause. But is this really the way Alzheimer's disease? And there have been people who have done each of those things and wrote new theory of Alzheimer's disease. But instead, do the numerous abnormalities, which are just huge, really mark something that's really different? In other words, a new state of the brain, and analogous to something that's like hibernation, that a neuron really is on a life preserver, and that it's phase shifted into something else, and that something else is so that it resists the risk of death. It's really critical that neurons don't die, because when they die, they cannot be replaced. They're not like the liver, where you can cut it in half and it'll grow back. So, and then the other point is, if you target any of these abnormalities, and this is definitely a hypothesis, if you start targeting any one of those 30 things, are you going to imbalance the survival because you're actually working against the biology of the disease? Okay, So that sounds pretty negative, okay. Well, some positive ideas. Because if you think of the disease as homeostatic, you're looking at something analogous to probably what's happening during heart disease. And what do you do there? You make lots of changes. And so this, along that line, is the people have been advocating things to reduce your chance of developing the disease. This is a book written by Gene Carper, 100 Simple Things You Can Do to Reduce Your Risk. But to really reduce the risk, and there's indications that reducing it can be as much as 50 or 90%. And the indications also that minorities have differences that are really distinct suggest things that you can do in your lifestyle will have a huge difference in developing the disease. Along that line, for our own case, we've suggested that the pathology of aging may be often a protective response. Maybe the reason we get gray hair and have wrinkles protects our skin. I don't know. I'm venturing out there. And the facelifts may not be the best thing to do. But I'm just saying that removing the amyloid may be not the best thing to do without understanding what it's doing. And lifestyle modification has been demonstrated to have substantial benefit. And these can be the 100 things there, and with a group I'm working with, the Alzheimer's Research and Prevention Foundation, where I'm Chief Scientific Advisor, we're advocating 4 simple things. And that is having a good diet, rich in vegetable products, fruits and berries, etc. Stress management. And stress management could be many different things. We're advocating yoga, but it could be a lot of different things. And exercise is being demonstrated, and it doesn't need to be marathon runners. It may not even be good to be a marathon runner, but having sustained exercise program, no matter what your fitness is. And spiritual fitness, having a reason to be alive. You know, the fact you're here today is improving your health, contributing to the total, having a reason to wake up each day. And that could be, you know, associated with a form of religion, could be helping your family, could be helping your community. If you want to go for the full thing, Dale Bredesen has written a book of 36 things that you probably would have to have 3 or 4 lifetimes to manage to do. And he claims that it reverses the disease. It's also important to know that a firm diagnosis is an important aspect, because I know people associated with his work that have said one of the things is that there's a lot of misdiagnosed people. And you know, if you have an older individual, you just say, well, they have Alzheimer's disease. It's important to know if they have other things, because there can be a lot of masquerading depression, other problems, and very correctable problems, especially if they're caught early. So Bredesen has this. I'm not endorsing the program. I'm just saying that lifestyle, you could do as simple as 4 things that I think everyone here could manage. You could do the 100 things, look at them. You could do nothing. That may not be the best choice. Okay, summary of my talk is that oxidative damage is an early feature of the disease. It's not just something that develops because everything's going bad during the disease. In fact, late in the disease, oxidative damage is extremely low. When it's high is during that time when you transition from being normal to having Alzheimer's disease. The energetic part of cells, the mitochondria, are critical to oxidative abnormalities. They correlate with it. They appear to be integral to it. We still don't know all the aspects in which they integrate. Amyloid is linked to mitochondrial metabolism and protection in ways that are still being worked out. Copper and iron abnormalities are intimately associated with plaques and tangles, and probably all the oxidative damage that I've described. And I think for this group, the most important thing is a cure for Alzheimer's disease, or at least a more effective treatment, which I think is where we need to really be focusing on, is things that really make a difference to delay the disease and give more years of healthful living. It requires understanding and targeting all the complexity of the brain, which is not just degenerating, it's responding and trying to protect itself. The brain is the most critical part of our body. When our brain dies, we die. So same as the heart. So the body is going to have tremendous compensations to keep the brain as intact as possible. And that needs to be understood before we do something, just pulling out all sorts of abnormalities without understanding it. So it doesn't mean there won't be a therapy related to amyloid beta or to tau or any of the other things, but they may not be as simplistic as just removing them from the biology. So I thank you very much for the attention and your patience in listening to some science. Let's see, questions? Yeah, I have a commitment teaching this afternoon. That's
Just a few questions. Let's open it up because you talked about the importance of research, finding treatment, or enhancing quality of life or cure. Talk a little bit about clinical trials. There's always a big fear and stigma that's attached to that about people participating.
Clinical trials and having patients for clinical trials and funding for clinical trials all are critical for advancement. There actually are not enough patients available in the patient base, especially in university-based program, because most of the studies are done actually separate from them. And I think it's best if the patients go to major tertiary centers to be involved. And the funding has been focused primarily for clinical trials on these very expensive amyloid trials, like the Biogen trial that failed cost at least $1.5 billion. And all the clinical trials, if they go to patient approval, will probably cost over $1 billion. But in order to have prospects for doing treatment, you have to have a lot of earlier trials, like phase 1 trial to show safety, because you critically have to show every agent doesn't cause damage to patients. You can't do harm. And secondly, you have to figure out in phase 2 whether, what dose you're going to give, does it look like it's worth scaling up? And that piece, there's actually not enough money. Not enough patients for doing the study and not enough money. And those are generally done by small companies that are most of the time underfunded. I'm associated with several of these. I didn't talk anything about them, but that's a common problem of them having that funding.
Do you know anything about the research in Denver that relates to that already?
What's that?
The research that's in Denver, that if you have RA, you probably won't get Alzheimer's.
Oh, you
even if
mean
it's in your
rheumatoid
family.
arthritis?
Right.
Yeah, because you're taking high levels of anti-inflammatories.
And that's,
Probably. I don't know that research is specific, but that connection of inflammation, and that was on my last list of all the possible things, is that inflammation is clearly a part of what's happening because the brain mounts an inflammatory response against the pathology and maybe even predates it. And so people thought that people would take high levels of anti-inflammatories. I'm not advocating that because there's a lot of gastrointestinal issues that you might have and you might die from taking it. But people with rheumatoid arthritis would do that because of their pain, so they would be in that group. I don't know about it being 100% protective.
I thought it was related to their DNA.
That I don't know. There's always, I don't know about that particular study, but I do know that like different ethnic groups, like at one time people in China said they didn't have Alzheimer's disease. Definitely not true, okay? They have the same amount. India is also saying they don't have Alzheimer's disease, and maybe it's because they eat a lot of curcumin, which may have protective action. But a lot of, Alzheimer's disease is a very socially driven disease and diagnosis. So if you have a family that thinks somebody's demented and just keeps them at home and never has them see a physician, in traditional societies that could happen, you could easily say, oh, there's no Alzheimer's disease here. And I don't know for the rheumatoid arthritis piece. I just know there had been studies like that in the 1980s by Patrick McGeer and related to anti-inflammatories. And they've never, when people have done prospective anti-inflammatories, they never saw a very clear effect. Doesn't mean that there won't be some benefit though.
One of your first recommendations for prevention was diet and supplements. Can you expand on the supplements?
Yeah, I took that from the 4 pillars because he sells supplements, okay? The supplement issue in general, and I do take supplements personally, okay? So I could say it, but the evidence is really poor. The benefits is more about eating the right diet so it isn't as simple as saying antioxidants like taking vitamin E and vitamin C is enough. There's a big difference between that and eating spinach and blueberries and other things because they're more complex. And the pharmaceutical industry wants to simplify everything down to one compound. But what appears to make the big difference is more complex things. So food is a varied diet. You don't have to be extreme. Doesn't mean you have to only eat blueberries. There's lots of other things. If you are deficient in your diet, then supplements do make a difference.
So most people need to take a supplement?
I don't want to get down that. I'm trying to avoid that. I told you I take a limited amount of supplements, okay? I take a multivitamin, I take some vitamin E, and I don't even follow the advice of an expert in vitamin E who says you really should only take the alpha one and the natural combination is pointless. I still take the natural combination, even though it may be pointless. It's also a placebo effect. But the reason why I think this is the case is even more complex than that. Then the reason is that when you're taking plant products, plants have a very special thing they do. They don't have claws, and the way they resist invaders and protect themselves is they form poisons. And that's what you're eating. You're eating a whole bunch of poisons. Plants are full of them. There's carcinogens in plants, and you don't need to be pesticides. They make their own pesticides. That's what caffeine is. That's what nicotine is. Those are all things that plants produce to kill insects. The other ones are to protect themselves from sun. They can't avoid sun. Remember, they can't move. So they either have thorns or they have poisons. And those poisons, which we resist the ones that kill us, probably induce protection responses. And that's something we study. So there's nothing wrong with eating plants. Just because they said they had low levels of poison, it's kind of a homeopathic effect. And you're not going to be able to get that by purifying any one compound. Because if you did, you probably have a real poison. It'd be too much. But you're not going to be able to eat that many cauliflowers or mushrooms or any of those things. But if you start purifying things, you actually can overdose.
Thank you.
And that advice, there's no indication that could have a negative effect on anybody. But supplements can have a negative effect on you. And most epidemiological studies show negative effects at high levels.
One more question in the back.
Oh, what is the recommended dose for omega-3, 6, 9? My physician has told me up to 3,000 milligrams a day, and the highest quality, is what I want. And for me, I can't eat enough salmon a week to fulfill my
how
need.
to evaluate that? I just had a blood test for this. There's a fairly inexpensive, and I don't know the address of where you get it from, because I send off and I'd have to look, for like $20 that they will evaluate your omega-3 in your blood. Because what you're really trying to do is get a proper omega-3, omega-6 ratio. Because historically our diet was higher in omega-3, And then our diet switched over to having food that tended to have omega-6. It's just where the double bond is in the fatty acid. And when you're eating more fish, and not all fish has an effect, it's only fatty fish that tend to be from the colder water, like salmon and some others. And because I was eating fish and then I thought I was doing really great, and I looked at their content of omega-3, and it was, tilapia doesn't cut it, okay? But there's some other fish that doesn't cut it also. Bacalao doesn't cut it either.
Well, you know what I had for dinner last night with you?
Yes, salmon, I saw you did.
I'm really happy I had the salmon last night. Any other questions? Just one final.
Do you see any correlation between anesthesia and triggering of Alzheimer's?
Great question. I mean, anesthesia, delirium, post things. Yeah, we had an issue. I'm editor-in-chief of the Journal of Alzheimer's Disease, and we had an issue on this, wow, quite a few years ago. If you ask people if you interview people that have family members with Alzheimer's disease, very often you find that they had some life event that happened when they developed the disease. Sometimes minor surgery, sometimes a fall, sometimes a death of a close person. There appear to be kind of, it isn't like you just go along and you suddenly go, it's more like something happened. And it looks like anesthesia does make a difference, but it's still, have you ever talked to an anesthesiologist about this? I have when I've had surgery, and they all tell me a bunch of BS. So I'm a pathologist, okay? I'm not a physician pathologist. And part of our department that I oversaw included the coroner's office, and I said, what's your biggest issue in, you have as a challenge? And they said, well, it's how to classify anesthesia-related death. Okay. Like, why did the people die during surgery? Was it from the, and then I went to the anesthesiologist and asked, and they said, oh, that's not true, and you were more likely to die driving here. So the answer is probably somewhere in between. Clearly, anesthesia changes, especially if you have open heart surgery. That's going to have an effect. And there's numerous studies that Jack de la Torre has reviewed. But that doesn't mean you shouldn't have anesthesia. And how do you avoid it anyway? That's why I'm always asking, can I have a local? And they get really upset with me. So I don't know what you do. I mean, I can't stand that much pain, and the surgeon is not going to want to do a surgery with you feeling pain, right, and moving. So is it a good thing? Mr. Biggs, he died within 1 year of diagnosis. And I asked his wife, why? What? And there is Alzheimer's disease that has a fast progression, but it's really rare. And she said, oh, he had a hernia operation. So I don't know if that's what, those things, but he progressed really, really fast after the surgery. So even a minor surgery. But remember, this is still anecdotal, I would say, because it's not really established. Pardon me?
I was just going to ask, do you know where his Alzheimer's was located in his brain?
I have no reason to think he wasn't the traditional pattern. Traditional pattern is it starts actually in some of the brainstem regions and then moves to the hippocampus entorhinal cortex region and then eventually spreads throughout the brain. And that's why you have different changes throughout. If the brainstem region is an important part, you have the unfortunate side effects of behavioral problems, which at least 1/3 of patients will suffer, aggression and other things. And as the disease progresses, you start to have executive function, judgment issues. Initially memory issues, later on judgment issues. And all of you know more about this than I do, since you experience it with real people you love.
Thank you, Doctor.
Thank you.
Thank you very much. Well, let's schedule your flight.
I think so.
Just wants to make sure he gets back to Texas for his biology class. Told him last night it was my favorite subject in school, not. Doctor, thank you. And I'm just going to also note that while I had the salmon, you had the bacon cheeseburger last night. And you look great. I think he enjoyed it a lot more than me. So does everybody have this on their table? Turn it over. There's a crossword puzzle. I'm going to ask for 3 minutes on the screen. I'm going to give you 3 minutes to get as many answers as you possibly can. Now we're going to test your brains. Starting now. And we are streaming live on Facebook, so if anybody is watching us on Facebook, they can go to the hardestcrossword.com and see the crossword puzzles online. Two minutes. No cheating. One minute. It's a long 3 minutes, isn't it? 30 seconds. $20. $10 seconds. 5, 3, 1. Put your pens down. Some of you seem very happy to put your pens down. So how many people got 15 answers? How many people got 10 answers? 5? How many people got 1? How many people got 0? Okay. How many people who were honest got 0? It's a lot more. We're going to show you a little video about why those who got 0 are the ones that got the answers correct.
My name is Will Shorts. I'm crossword editor for the New York Times. This puzzle has a special story behind it. Only one person knows all the answers, but she doesn't remember them anymore.
Alzheimer's is a devastating disease. We wanted to demonstrate its effects and show how the AFA can help. So we took a common hobby and transformed it into a way of experiencing the disease. First, we learned facts about patients' lives by interviewing their relatives.
My grandmother is Catherine. She had forgotten to feed the dog. She found a doll, named it. My dad's name is Richard. My name is Doug. Dad completely burned the fried chicken.
Then, we had Will Shorts create puzzles based on each patient's life and the answers they could no longer find. We worked with the biggest newspapers in the United States to have the puzzles covertly published, making enthusiasts struggle to find the simplest answers. In addition to the newspapers, a range of media drove people online, where they could learn more about how the AFA can provide support. We showed the effects of Alzheimer's through a crossword puzzle that not a single person can solve. We reached over 5 million newspaper readers, a total of 50 million adding other media. AFA saw a 159% increase in web traffic and another 62% in calls. And with unsolvable crossword puzzles, we helped many find the answers they needed.
So only if you knew the three individuals that were interviewed and their families would you be able to solve the puzzles and give the answers. But for a brief moment, for 3 minutes, you experienced maybe a little frustration if you love puzzles and you couldn't answer this, a little confusion as to why you couldn't solve a simple task. So I was contacted a number of years ago by a healthcare public relations firm in New York City that just wanted to give back. We met with them and they wanted to come up with an initiative that would challenge individuals. So they contacted Will Shorts, and if anybody loves doing the New York Times crossword puzzles, you know a little bit about Will Shorts, who's the editor of the crossword puzzles for the New York Times. And he came aboard. We were delighted, obviously, and privileged to have him participate in this initiative. And as you can see, we placed the puzzles in major newspapers across the country. So can you imagine opening up a New York Times on Sunday and you're an advocate of crossword puzzles and this one you can't solve? So for that moment, you got to experience, just for a brief moment, what confusion is all about, what somebody living with this disease experiences 24 hours a day, 7 days a week, and obviously the caregivers that goes along with it. So how many people here are caregivers? Personal? Professionals? Okay. I'm going to show you a little video about, a little bit about AFA. I'm going to talk to you a little bit about our organization before we go into our next workshop. Show the Uncle Sam video.
My last 8 years in the city, and for my brother's last 11 years in the city, we took Sam out to lunch once a month. So we had a routine. We'd meet him at the diner around the corner from his apartment. And the first time it dawned on us that there was an issue is when he didn't show up. We were scared, we were running around, and then we finally went and saw him in his apartment. He just forgot about it. And from then it was kind of like progressively a downward spiral. And then when we knew it was a major issue was when he was cooking and forgot to turn his stove off. And at that point it was, you know, we have a real issue here and we need to start looking for resources to help us navigate through this and figure out a solution for him. Sam was a young boy when the Holocaust broke out. He was living in Poland with his family. He was brought to 3 or 4 different death camps and was able to survive all of them.
Concentration camps, ghettos, liberated by the American forces.
He's lived an unbelievable life. He's an inspiration to me every time I see him. It's really troubling when you're watching someone and they're losing their mental capabilities, and they're losing their memories, and they're losing who they are as a person. It strips everything that you've built an entire life for and everything you became, and it turns you into someone that you're not. It's a debilitating disease that it's going to affect you, and it's going to change the person that you are, both mentally and physically. And it also has a great effect on your family members, because it's very difficult to watch someone that you love go through such a tough time. He's probably written his life story 35 times. And I think it's because he doesn't want people to forget what he's been through. And it's just so ironic that as this disease has taken over his life, you know, he's starting to forget his own memories. And so here it starts, and it's talking about him and his life, and then we're a third of the way through the book, and he starts over. And so he writes his name, that he was born on December 1st, 1922, and then it goes through his whole story once again. Told me he was scared. He knew he was starting to lose it and his memory was starting to go. He was vocal to me and said, you know, I need help. And I need to get out of my apartment, and I can't live by myself anymore. Dancing it's his pleasure. Dancing to music is what it makes him happy, it makes him tick. He used to be very active. He was always going to the senior centers in the city. He was around people, he was dancing, he was happy, he was loving life. So where Sam is now, he can't dance anymore. He hasn't been dancing for the last year. And the hope is when he moves into the facility, he'll be able to start dancing again. Having a network of people to tap into, the Alzheimer's Foundation, they introduced me to a group of nurses that have been able to take care of my uncle. You know, for a man that's been able to, you know, beat almost everything else, to know that this is one he ultimately isn't going to be able to beat, it's tough, but there's hope. There's hope for him to find a cure. There's hope to make the rest of his days on Earth better. What I think will make his life more enjoyable is getting into an assisted living facility where they have the tools and resources to help people in his situation. No matter what hand you're dealt, it's really your attitude and the way that you go through life that's gonna, you know, ultimately decide the way that you live your life. And as long as we keep on fighting, there's hope.
So the gentleman, the young man, Jared Finkelstein, came to us a number of years ago talking about his great uncle, Sam. And we had met Sam, and we were able to place him in a member organization of the Alzheimer's Foundation of America. And you have some exhibitors in the back that provide services in your area. I encourage all of you to sit down and talk to them. But Sam was in a place called the Lot Residence, which overlooks Central Park. Beautiful location. And I had gone to see him, and I must tell you, the first time I went to see him, I didn't recognize him. He was well-kept, well-groomed, looked like a totally different person, and was dancing. I actually walked into a therapy program, a physical therapy, and they were hitting beach balls all over the place, and he was the most active one. He was doing so well there, and he was dancing, that one day while he was having lunch, he was at a table, and there was a woman across from him that wasn't eating. Put down his own fork and knife and went across the table and sat next to her and started feeding her. So it's 4 years, and we recently lost Sam, and I must tell you, it gets very emotional for us at AFA to see this video. But he, his first year there, he gained the freshman 15 pounds. He looked terrific. He had a girlfriend, and he was loving life. So we were happy to participate and enhance his quality of life. And I thank all of you for taking a look at that, because it's very important to us. So our mission at the foundation is to provide the support, the guidance, and the counseling that's critically important to caregivers. We do that every single day. And our initiative with the National Educating America Tour is to be here today in OKC because more than 60,000 people in your state are currently living with this disease, and as you know, more than 5 million people nationwide, and the services of care are so critically important. We were founded because our founder, who was a caregiver at the time while he was caring for his mom in the 80s and 90s, nobody talked about Alzheimer's disease then. They used words then that we don't use today. But there was no place to turn to. And he experienced a lot of frustration while caring for his mom because he had nobody to talk to. He'd leave, he'd walk out of the kitchen, go into the den, come back, and she'd yell at him and say, "Where were you? Where have you been? I haven't seen you in days." He'd get frustrated. And he'd say, "Mom, what are you talking about? I just walked out." He'd take his father to the movies, come back, again, the frustration, the agitation that he would experience, he didn't know how to deal with. But before this, they were living in Florida, and he's from New York. Notice the change in his parents. When his mother said to him, "Bert," his name is Bert Brodsky, "Bertie, don't worry about it. I took Dad to the doctor and I saved you money. The copayment was only like $1." He found out that she took him to a pediatric clinic in town. So he knew there was a problem. So he wanted to put a healthcare worker in his house, in their house, and she said no. He took the extreme step and he sued his parents. And he walked into a courtroom down in Florida, and the judge said, "Brodsky versus Brodsky, how much money is involved?" And he said, "Your Honor, there's no money involved." And he explained what he wanted to do. And he said, "Mr. Brodsky, this is Florida. When the same name is on either side, there's money involved." He says, "All I want to do is put a healthcare worker." Judge looked at his mom and said, "Don't let the court make the decision." So she went and made the decision. He had a healthcare worker. As he saw their cognitive changes in them, he knew he had to bring them to New York to live close by him, had a healthcare worker in there. She passed away in the 90s, and he knew that he had to do something. So he founded AFA as back then, 17 years ago, as a place to go for guidance, for referral services. It was originally, he founded what was called a hotline. It's now a helpline. We now have a national presence of nearly 3,000 member offices nationwide, including many here in Oklahoma City. And our programs and services are not just a hotline, which is now our helpline. It's all these programs and services, national memory screening, and I want to remind all of you, we are offering memory screenings here today. Just see Amanda, and we will provide you with the free memory screenings. Our partner in care dementia training is specifically a dementia training for professionals and non-professionals. But so many other programs we offer, webinars, teleconferences, to ensure that we're there. We've trained more than 19,000 people through our professional training that deliver counseling and support, obviously, to tens and thousands. And our memory screening initiative is a decade old, and we've screened more than 10 million people. 5 million people. We now have it online, and the first time online last month, in the month of August, more than 10,000 people took the memory screening test. So I asked you the question before. Are you still afraid to take a memory screening? Okay, who's honest with me? Who's afraid to take a memory screening? Okay, Amanda doesn't bite. She's a wonderful person. It's 10 minutes. It's confidential. Our helpline is staffed by licensed social workers, and as of this Saturday, we're expanding the Saturday's hours. Monday through Friday, 9 to 9, Saturday, 9 to 3, and Sunday as well. 7 days a week, staffed by licensed social workers. If you call, you're going to get a response, you're going to get an answer, you're going to get the help and the guidance and the support that you're seeking. And if you just want to talk to somebody about memory issues that maybe you're experiencing or a loved one, pick up the phone and make the call. The number is 866. It's in your agendas as well. Part of what we do is we give back every year the support that we receive, nearly $1 million a year, to support our member offices, and we also fund research all over the world, whether it's for a cure or for better treatment as well. We have a public policy division in Washington that continually fights for money for caregivers, for caregiving support, because all too often that's forgotten, and also to fund research. And for the first time ever, the federal government finally appropriated more than $2 billion for research dollars. I'm hopeful in the next budget, it will be close to $3 billion. And you heard the doctor about a failed trial that cost over $1 billion. Well, if we're going to find a cure and better treatment, we need more research dollars. And we're hopeful because our public policy division in Washington is trying to get the federal government to recognize this as a national epidemic. And not something that politicians can say that, oh, this is great to talk about. But this is a serious issue that needs to be addressed in this country as well. On November 7th of this year, we started an initiative a few years ago. It was called Light the Nation in Teal. Teal is the Alzheimer's awareness color of the Alzheimer's Foundation of America. It spread so quickly that historical landmarks throughout the entire world now light up in teal. And we're delighted that this year, more than 300 buildings, bridges, you name it, will be lit up in teal all over the world. And what does it do? It heightens the awareness of this disease. It starts the conversation, and then hopefully people pick up the phone, whether they call the Alzheimer's Foundation or any other advocacy group or nonprofit. It's so critically important that you make that call, because you as caregivers know you cannot do this alone. And we believe that you need a team, and you need a team of support as well. Our conference has been all over the country this year. We're delighted to be here, but it doesn't end. We're going to be in Seattle, Washington, and New Jersey, and other facilities. Then we just turn around in 2020 and we continue the educating tour. You know, we put them on for free. We don't charge anybody because we're fortunate enough to get sponsors that support us, which is really important to us. But we believe that our work is never done. You know, I always say this with all due respect to the staff of AFA, that it's never enough, because the disease doesn't discriminate, it doesn't sleep, it doesn't take holidays, it doesn't take any time off, and we have to continually do everything we can. So I thank you so much for being here. We're going to take a quick 5-minute break. There are some beverages outside. The restrooms are to the right of us, and then we'll be back in 5 minutes. Thank you very much.